So welcome everyone. Thanks for taking some time. My name is Ronn Jefferson. I'm the product manager for Geberit in North America. I'm really glad to be here today. The sun is kind of in and out here. I'm in Chicagoland. With me helping out today, or actually the brains behind the operation, is Sarah Barnhart. She's moderating the event. Thank you, Sarah. She's also in Chicagoland, and also last minute addition, Jacqueline DeBergeris, who is sales in New York City, and she'll be helping out with the Q&A at the end. So thanks to you both, ladies. I couldn't do it without you. Now to start off, I'm gonna keep it simple today, or try anyway. The goal is not to turn you into experts, but arm you with some basics, enough to make you dangerous. This is when I would use a winky emoticon in my text. So in the next 30 minutes or so, I'm going to show you some basic rules for planning drainage and venting systems for Geberit in-wall systems. This includes proper installation behind the wall, how to join Geberit fittings with the main drainage system, some common installation scenarios for above the floor and below the floor drainage, as well when and how to use Geberit accessory fittings, and then finally a Q&A. Before we dive in, I want you to set the mood. Take a look at this beautiful bathroom, and of course what we're going to talk about today is the piping that's you don't see now but behind the wall. So before we go further, let's take a short refresher and show this video that walks through the installation steps of the Geberit in-wall system in a 2x4 renovation. So first is setting the bowl height above the finished floor here inside the wall, and preparing the studs and the frame itself. Next is adjust the frame and attach it to the studs. The next step will be to connect the waste outlet to the drainage pipe and the venting system. So the waste outlet for Geberit systems, or toilets in general, is a 3-inch connection, which you will see here shortly. Coming up, it gets attached via a flexible coupling. In this case, it's shielded to the drainage system. Then, of course, we have water supply behind the wall, and also connecting to the filling valve to fill up the tank. And then finally, finishing the wall and attaching the toilet. And ending with a nice finishing touch of the actuator. Now that that's finished in our minds, let's go for the topic of today. Let's talk about drain waste and vents, especially for in-wall systems. Now on the right-hand side, you see this diagram. It looks to me like it's a building that inside is filled with kind of spaghetti. But really, it outlines what we're going to talk about today. So the question is, what is drain waste and vent system? And for this, I use the City of Chicago Plumbing Code as a source. It defines a drain or drain waste as any pipe that carries wastewater or waterborne waste in a building drain system. I think that's pretty straightforward. You see in the diagram, you see bathtubs and sinks and a wash tub and toilet, for example. Anything where water is going down the drain, as we like to say, that's the drainage system. Now the vent is another part of the system, and the definition of that is it's a pipe that's provided to ventilate a plumbing system to prevent trapped siphonage and back pressure, and to equalize the air pressure within and without the piping system. Okay, but what does that really mean in the real world? Well, it really says kind of two things. First, all the fixtures have a vent, and this is to make sure that the trap is sealed. This helps to keep sewer gases out of the house. The vent takes the sewer gases and helps equalize the pressure so that this doesn't happen. The second thing is that it allows air to go into the pipes, and that air is required to help the waste flow smoothly and silently. So to eliminate the kind of gurgling noises that you might hear when there's an issue like that. So basically, when we talk about DWV, we're talking about all the pipes in your house. Typically, this is defined to be up to your sewer, so everything inside. So, well, specifically, what does the code say about DWV and toilets, especially wall-hung toilets? Well, I did a comparison of major codes here in North America: the UPC, Universal Plumbing Code, IPC, International Plumbing Code, the City of Chicago, and New York City, and more or less they all basically say the same thing. Though I see Tom Brown here, I apologize I didn't include Massachusetts. But anyway, as we continue, they all more or less say the same thing, that for toilets, the drain must be a minimum of 3-inch size, and for venting, every fixture must be vented. That means every sink, every toilet, every bathtub, every shower, they all have to have a vent. And typically for toilets, that means a minimum size of 2 inches, and that should be no more than 8 inches away from, or 8 feet rather, away from the trap. So you can see in the diagram here, let's take this bathtub, for example. This is the trap, and here's the vent itself. It's not directly at the fixture, it's a little bit off. So that this distance can be up to 8 feet. And finally, the vent, typically it has to go straight up first, and then it can go off to the side. This is to make sure that nothing gets stuck in it, for example. Now, the other funny thing I should point out is when I did the comparison between the codes, it seems like Chapter 9 is the one that's for venting. It's kind of a universal thing. Now, these are kind of starting values. As you add more and more fixtures to the system and they get tied together, the sizes are required to go up, and I'm not going to talk about that. Now you're sitting there saying, okay, Ron, that's great, but what about in-wall specifically? Well, the good news is that the same rules apply whether it's a floor-mounted toilet, a wall-hung toilet, an in-wall tank. There's absolutely no difference. And today's notes are based on our planning guide. You should check it out or contact us. It's a 12-page guide for in-wall systems that helps you plan, specify, and install projects for in-wall systems, as well as it starts from product selection all the way up to wall construction and, of course, the plumbing itself. It does include examples of DWV that we're going to talk about here. It's not exhaustive. It's just some common examples. And in the end, always please have to consult a local contractor for specifics or a local inspector for questions and local code needs. So it's a great sort of catch-all, a great sort of starting point. Now, before we continue, I have to stop and point out something that's really critical. This is an area where installation can go wrong and does go wrong, and it's about the orientation of the waste behind the wall. In the diagram, you see a waste that's going straight down vertically, and then two different configurations off to the side at a 45-degree angle. With respect to the vertical installation, this is the ideal. Gravity is 100% in our favor there, and of course gravity is what helps the waste move down. So that's a great solution behind the wall to come out of the carrier frame and then into a 90-degree and straight down. But sometimes that's not possible, and sometimes it's not desirable. In those cases, we can go off to the right or left in the horizontal direction. But in this case, it's really important that before going to this really shallow horizontal, that the waste pipe be angled between 0 and 45 degrees from vertical, as shown here in number 2, and has a drop of at least 1 pipe diameter before transitioning to this much lower slope. Without that, the waste just sits in the bowl and then no one's happy. So remember, vertical to 45 degrees is the ideal behind the wall, or out of the tank system. All right, we talked about what's behind the well. We talked about what's drain, waste, and vent system. We talked about proper orientation of the product. Now, how do I connect that to the system, to the DWV system? How do I connect your product, Geberit, to the DWV system? Well, Geberit, there are 2 types of fittings coming out of the tank system. There's one that's HDPE, which is a plastic material, and then one that's cast iron. And from there, the drainage lines can be plastic or metal in different sorts of colors and flavors. And then there are different types of connections. The first type is a flexible coupling. This is probably the most common, and it's used to connect the plastic Geberit or cast iron Geberit to plastic or metal drainage piping. And these flexible couplings can be standard, as here, the black with the silver bands, or shielded, which is an extra layer of security as a metal strip all the way around. So in all cases, all Geberit fittings can attach this way. The next type of fitting is called a no-hub coupling. This is also a type of flexible coupling, but it's specific for cast iron. So in this case, it must be connected to a cast iron fitting from Geberit and then a cast iron fitting in the drainage line. Third way of attaching pipes in the system is to glue them. However, HDPE does not glue to other plastics, and in fact, it's dimensionally different. So gluing is definitely out, and gluing plastic to cast iron also doesn't work. So this is not an option when using Geberit or in-wall systems to connect to the drain, waste, and vent pipes. The fourth type of connection uses a gasket, where it's kind of a push fit. This can be used with the plastic as plastic pipes with HDPE from Geberit, or with cast iron from a Geberit fitting to metal, specifically cast iron fitting out in the field. It doesn't quite work in the other dimensions. And then finally, especially here in Chicago, a way of joining is to use lead and oakum. It's called in the hub and spigot configuration. And this is specifically for cast iron to cast iron. What it is oakum is a hemp-based material. It gets placed in the joint to seal it, and actually expands when it gets wet. And the way they do that is the plumber pours in molten lead to do the expansion. So out of these, the flexible coupling is the most common in the market, followed by the no-hub, and then lead and oakum, surprisingly. Given that it's flexible couplings are the most common, the question is then, which coupling should I use? Where should I go? Who should I talk to? You see here a chart that's outlined a few things. Across the top is the dimensions, the size and material of the fittings that are to be joined together, and then 3 different manufacturers, Fernco, Husky, and Mission. So this chart says that for a 3-inch plastic connection to a 3-inch plastic pipe, you would use one of these 3 fittings, or they would recommend one of these 3 fittings, and so on. So in this chart, there are different combinations. So 3-inch plastic to 3-inch plastic, 4-inch plastic to 4-inch plastic, 3-inch plastic to 3-inch cast iron, and so on. And in the chart here, PL is plastic, CI means cast iron, and K is copper. Those are industry abbreviations. Additionally, I've included, which you'll get in the replay, links to they have their own online selectors that can help to answer any questions or find the specific couplings if you have other types of connections. Now with the Geberit products, it is supplied with this Fernco coupling 3005-33 for 3-inch plastic to 3-inch plastic. And the reason that it's supplied like this is because most of the installations are in a residential situation, and that's typically ABS or PVC plastic pipes that are being connected to. However, in let's say in high-rise or in tall buildings, for example, the situation changes. In that case, sometimes it can be that the plastic fitting from Geberit can be attached to cast iron, and that would require a separate coupling that needs to be ordered, or replaced with a cast iron to cast iron fitting, an additional coupling that would need to be ordered by the contractor. So this is important from a planning standpoint to know that, to ensure that the proper materials are ordered and ready on the job site. Now that the building blocks are out of the way, let's focus on the two main configurations of DWV system. As you can see, we got above the floor, where the drainage is actually running above the floor, and then below the floor configuration where the drainage pipe is actually running below the floor. Oh, but why one or the other? What makes them different? What makes one better or more desirable than the other? Well, typically an above the floor configuration is used in the commercial setting, and I'll explain why here. It offers a great cost savings for running above the floor, especially in concrete floors, or any case where going through the floor isn't really the best situation. This could be, for example, in a basement bathroom. It's also in tall buildings, often use post-tension slabs. What that means is inside the floor, the concrete floor, are these cables which are under tension. So you can't just go around drilling anywhere. You have to come and have a special crew to come and find out where the cables are, and it really limits the amount of drilling that can be done, or the placement. It's also very expensive. Some other situations could be not wanting to go into a CLT joist, and this is one I've run into many times actually here in Chicago, where they're trying to renovate a historic building inside. They really limit the what can be done, and so by running the pipes above the floor, there's no need to kind of drill through the concrete and do some of these other things that are actually just not allowed in those cases. So this helps eliminate additional waste stacks, which could also help to eliminate material cost as well, or reduce it rather. Additionally, running the pipe above the floor means that they don't need to be in the ceilings of the floor below, which means that the distance between floors can be actually reduced. This can lead to taller ceilings, or it could mean that you could add more floors to the building, for example. And then finally, running the pipes above the floor gives some flexibility to locate fixtures that might not be otherwise possible. Below the floor is more typical of a residential applications, especially where there's access from below. So imagine you go into your basement, you see the pipes above you, or you go into a crawl space, for example, in the ceiling of the crawl space, you have access to the pipes. This is, I think, the main advantage there. The chart you see now outlines accessory fittings that contractors can order, or architects or plumbing engineers can specify, for example, from Geberit to support different installation situations. On the left-hand side are show fittings that can be used with above the floor drainage, and on the right-hand side for below the floor drainage. These include a 3-inch, the 3-inch elbow, which is included in the base package here, a 3-inch cast iron elbow with a 2-inch threaded heel, a straight connector, some offset connectors, and then a few back-to-back fittings. Now, with all this information, you should be able to better picture now what above the floor means and what kind of fittings could be used from Geberit. So I'm going to start with above the floor here. Remember, the same rules apply as for all toilets. Minimum 3-inch waist, 2-inch vent located no more than 8 feet from the trap. So keep that in mind. And I go through 3 configurations, or you can see the drain line here. This dark blue is the waste pipe. So this first scenario is installation of a Sigma 2x6 or 2x4 in a wall cavity that's 5.5 inches or deeper. That's enough space to run above the floor. This is also can be replicated using the Omega 2x6 carrier. However, this 2x4 carrier and a 2x4 wall does not allow enough room for pipes to run above the floor, so this is not an option. This would be the case of any type of system. A 3-inch pipe is physically too big to run into a 3.5-inch cavity or 2x4 wall, so that's just not an option. A common scenario in commercial applications is to have ganged toilets or multiples in a row. In this case, you can see here that this behind the wall distance changes, or the minimum required changes depending on the configuration. So if it's for no hub pipes, you need a little bit smaller wall. If you have a hub and spigot configuration, then it needs to be a little bit deeper. This is because hub and spigot fittings are, by their nature, actually larger in diameter. So this gives some guidance to the architect or the plumbing engineer and what types of minimum space is going to be required to do such a situation or to do this. Now you can see in this, also in here, that the 45 degrees I was talking about earlier, that's ensured by this design. In fact, this offset fitting incorporates the 45 degrees directly into the fitting. So it's actually a space and time saver for the installer to do it that way. Now moving on to below the floor. So starting with the Geberit Sigma 2x6 or 2x4, again, those products can be installed in the wall cavity 5.5 inches or deeper. That's equivalent to 2x6. Omega 2x6 also can be done in this way. And in this case, even the Sigma 2x4 in a 2x4 wall at 3.5 inches is possible. Next, I'll show you a back-to-back situation. Again, this is more typical in a commercial setting where toilets are in one room or on one side and then on the same wall or directly opposite each other in the other room. In this case, again, there are some minimum distances required to make it work depending on the size of the carrier, from 8 5/8 to 11 inches. And there are 2 different fittings that can be used for back-to-back. The top one here is for running above the floor, and then the second one is for back-to-back where it's actually the waste is vertical and the drainage pipes run below the floor. So it works in either configuration. So that was a lot about drainage. Now I'm going to talk specifically and focus on venting here. Some codes require to vent above the weir of the trap. What does that mean? It's code speak of saying it's the high point of the trap. That means that the vent itself can't go below the floor. So the vent has to be more or less something like this in this orientation. And each of these diagrams illustrate a different way of doing this. The key is you have to have some kind of a fitting that has a heel outlet, like as shown here. The heel is this little area here. Like our cast iron fitting, for example, and also it requires a bit more room to make it happen, and we'll talk about that in the next slide. So there are rules that need to be followed to ensure that everything fits and works. This is important because, well, frankly, the tank tends to get in the way, and so it limits how and what can be done to take advantage of the option of venting above the weir. So in the first illustration, it's a vertical waste, so below the floor drainage, and that requires a wall cavity that's greater than a 2x6 to make it fit. It's physically not possible to do it with conventional fittings and meet all the requirements in a standard 2x6 wall to have the vent in this orientation, vertically straight up directly behind the tank. The second situation is also below the floor drain, but with offset venting. So the vent is, instead of going straight up, it's coming off to the side, away from the tank. In this direction, also is required to have a deeper wall than a 2x6 to fit everything, because there's some other bits behind here that get in the way. But running the vent in the opposite direction fits within a 2x6 cavity. So it's the difference of the direction makes is important for planning. Now, changing this scenario 2 to number 4 and putting the drain above the floor and running in the same direction, you actually run into the same situation, the same challenge. There's some bits over here that get in the way, so that requires a wall cavity greater than a 2x6. But if the vent were to run in the other direction, this way, then it can fit into a 2x6 cavity. All right, now that I've taken all the official stuff out of the way, I'm going to play you a short video about Geberit. It's a brand new company video.
Oh, wie geht das genau?
And what about the pipes?
Huh?
Und was ist mit Schulung? Und was ist mit... Und was ist mit... Und was ist mit...
Fertig. Fertig.
Whenever I see that, I wonder how they get Boris Becker and Patrick Stewart to agree to be in the video. But I'm just kidding. Check it out on the website or on YouTube. Share it with the clients. So DWV, I hope this helped you today. Both you can leave from here today and take something away and use it right away, or it can help you in your future daily business. We talked about some basic rules for planning drainage and venting systems for Geberit in-wall, including proper installation behind the wall, how to join Geberit fittings with the main DWV system, some common installation scenarios for above the floor and below the floor drainage, including singles, ganged, back-to-back, and then when and how to use Geberit accessory fittings. So now that you're armed with this information, I encourage you to dig deeper, take advantage of our online tools, including our locators to locate a showroom, trained installer in the area, set up and request a sales call or a training. Also download, read or distribute the planning guide that I mentioned before. Check out our social channels, and always, if there's any questions, contact our customer service or tech support via phone or email, or our very knowledgeable sales team, sales reps, and of course, yours truly. And with that, it's Q&A time. Hit me, Jackie.
Thanks, Ron. That was very informative. We have a question from Tom Brown. And what is the maximum horizontal run before a drop is made?
All right, thanks, Tom. I'm guessing this is about the drainage line out of the toilet. I usually use around 20 feet is what we recommend as a maximum for most installations.
Great. Thank you. And we also have another question from Barbara. And she's saying if we want to put controls on the side of the unit, is it up to the plumber? I'm assuming she's talking about possibly maybe just remote actuators, if that's correct, Barbara. If that's what she's talking about in regards to controls.
Then the answer is yes.
So I think it's more geared towards just a remote actuator, possibly on the side, if you want to maybe quickly touch on that.
Well, in those cases, it could be up to the plumber, but it also can be up to the end user, the architect, the designer. It is important, though, that to plan that in advance, because it does require some additional work behind the wall. There's actually an air hose that is run behind the wall that connects between this remote push button and goes into the tank that activates the flush mechanism. So it could be up to the plumber, but I would say if as early upstream as possible, the decision and the planning should be made. That makes a big difference in the ability and the outcome.
Great. Thank you, Ron. And we have one other question from Scott, and I think he's just asking if we plan to have any Geberit's toilets launched here in North America. If we're
not at this time.
Not drain related, but always a valid question. And that is all.
Great. I thought we were talking before in the green room, Jackie. I thought you maybe had a question you wanted to ask.
I thought it was fairly thorough. You had mentioned some other couplings that could be used if necessary. So that was cleared up. I appreciate it.
Oh, good. I'm glad I was able to answer your question then.
And that's all we have in the queue for questions. It was very informative. Thank you, Ron.
Well, thank you, Jackie, and thank you, Sarah, and thanks to everyone else. Again, please take the survey, and we will send Q&A and combine it with Q&A from the next group. I have a few other things I can throw in too that I thought of actually in the presentation that I'll throw into the Q&A. We send it out, and you should expect the link to the replay in a few days. So with that, I wish everyone a good rest of your afternoon. Thank you, and talk to you soon.
Thank you.